Good morning. It's Thursday again. Wow, time flies like an arrow. Welcome to my Twitch stream here, and thanks for coming back if you attended the previous sessions. What is this about? Oh, just a second, I forgot to close the window blinds. So, there's always the setup procedure before getting started. It's a long list of things to do, and I made a checklist. And today I skipped the checklist. I don't know why. So bad if you do that. So again, let me restart that. Welcome back if you attended the previous sessions. What is this about here? In this stream here, I'm trying to solve a problem that really isn't a problem anymore. Meanwhile, this is episode number 4 here. But the original story is that I was looking at my son's homework, and as part of this homework, he had to find words in what is called a word puzzle. If you look at the screen, you can see this here. So a word puzzle is like a grid of random characters, and there are actual words hidden within this grid. So you can see there's the word fun at the top left, for example, and there's kitchen right there, written from left to right, and there may be other words either hidden vertically or diagonally, whatever. And he had trouble finding the remaining 2 words, and he asked me for help, and I was pretty much unable to answer his question because my thoughts were somewhere else. My thoughts were, wouldn't a computer be able to solve that? And that started and kicked off this project, which you can find over on GitHub. So the project is complete, it's there, you can have a look at it. And I'm gonna share the URL here. Let me see if this works. There we have it. So this is, if you look at the chat window, where you can find all of the source code and the information. It's also all documented there. It's not just the pure code, it's an actual tutorial that shows you the individual steps that have been taken and what to do if you wanted to recreate that thing. So this is, as I said, part number 4. Let's quickly recap what we did in the first 3 parts. And today I'm joined by my new co-host here, Mr. Monkey. There he is. Hello. So in the previous episodes, I introduced the concepts, I introduced the components that are used. So that involves Azure Blob Storage. We installed the Azure Storage Emulator and the Azure Storage Explorer to be able to work on this locally. I talked about how we're going to end up having some client app, and although this is, it's a smartphone here, doesn't mean that it has to be a mobile client. The test client that I'm going to add as part of this stream here will be simply a console-based client. Maybe we're going to do a follow-up where we talk about the mobile parts. Mobile clients, I think that's actually a good idea. And I've got a promise here from Kim Philpotts, who was on the first episode, and he said he'd be back when we talk about the clients. He's very good at designing the UI, so we'll have a look at that. Right, so the idea is that we have got some image that we take as an input. We either scan that or we already have it. Anyway, we upload it. To upload it, we're gonna leverage blob storage and Azure Functions. We did this last time. The Azure function is there to give us a URL that we can then use to upload to. So we talked about shared access secrets there. So we can directly upload to blob storage. Uploading to blob storage, that triggers another Azure function, which is also what I added last time. This blob triggered function is then reading the blob from the storage. And its job would then be to, well, read the image and split it up into individual sub-images. To do that, I added a library. That library is a .NET Standard library that we can use in our test applications locally, and we can of course use it later on in the cloud or from directly within our Azure Functions. This library is there to, well, split the image, and to achieve that, I used a library that is called 6 Labors Image Sharp. You can find all of this, like I said, in this documentation here. And where we ended last time, that was in here. So I gotta look at that, I gotta find it. Am I looking at the right thing? That's always the question. Too many projects open here. Yep, there we are. So this is where we left last time. This is the function that I added, and it's triggered by a blob whenever we upload something to a blob container that is called word puzzle uploads. And I simulated that by going in here. Let me check out, there's the storage explorer. Here we see our storage explorer. It has got this container word puzzle uploads, and there one image has been uploaded. And not only is the image in there, the other thing that I explained last time is that you can open up or show the properties. Oops, here's the image. So there we have it. This is the image that we uploaded. And if you look at that image, it's not just the words, it's not just the random characters, there's more. There's a header in here, and it has got a vertical and a horizontal offset. So not only do we have to upload the image, we also need to provide certain additional information that explains or lets the processing function know, well, where does the first character actually begin? Where is that located? And what's the width and the height of the cells that we're looking at here? And how many characters are there vertically and horizontally? So how many rows and columns do we have? That means we had to find a way to provide this data. And if I open up the properties, then we see that saving a blob on Azure Blob Storage does not only allow for storing raw data, it also allows for adding this metadata here. And I added a whole lot of metadata, like the height of each of the cells that we have here, the spacing horizontally and vertically between the cells, and the width and the number of columns, the left offset, the top offset, and of course, a list of words that we expect to search within that grid. All of this is meta information. Now, while I'm demoing this here and using that and using a console-based client, it's a bit hard to find the correct values. I mean, it's relatively easy to find that there are 14 columns and 14 rows, but these values like the cell spacing vertical and the horizontal, if you go back to the previous stream, that is also all available on YouTube, by the way, it's preserved there, you'll find that it takes a bit to play with these values to find the correct ones. If we had a rich mobile client, for example, or a desktop-based client, we could easily figure out these values by letting the user scale some sort of grid on top of that word puzzle and align that, and if it matches, then we can deduct the values. But for testing, we have to find them manually. Anyway, as soon as I change any of these values in here, this is going to trigger this function here. And that function will then read the blob. It will also read the additional information, the meta information in there. And using that, it's then calling our helper method. This is the split image method, what we added to the .NET Standard library. And split image takes as an input the original image as a stream, all the information about how many columns, what is the spacing, and so on. It then runs our actual splitting code. This is what we implemented last time here. And it returns back a list of streams where, and this is what I forgot last time, I got to look that up. This list of streams that is returned here, it is columns times rows of images plus one additional image. The additional image, this is the original image with some grid overlaid on it, so we can verify that the values that we use, they are the right ones. So all of this is returned as a PNG and returned as a stream. And so let me check the last one. So the last one is the last one in this list. This is the original image plus the overlay. And the others, in our case, that's 14 by 14, that's 196. They are the individual character images, I think. Cell highlight image, cell highlight, yeah, correct. So that means from 0 to 195, these would be the streams that we now have to further interpret. So this is where we ended last time. We've got 196 individual images, each image representing one single character. And now, in order to find words, we need to pass these over to something that can turn our binary image information into ASCII codes. And that is where we need custom vision AI. So what is custom vision AI? To show you that, I'm going to switch over here. Custom vision is something that is available also via Azure, and you can find this conveniently at customvision.ai. Now I'm gonna put this here on the chat window, customvision.ai. You can go ahead and sign in there. I recommend signing in with your Azure account, and then, well, you're ready to get started. You can create your own project. Custom vision is always useful if you've got a task where you want to either classify images or recognize something in image. So these are two different things. Here we need a classification. We've got a set of 26 possible images, the letters A to Z, and we want this service to figure out, well, what are we looking at here? Is this an A, a B, or a C? Initially, when I thought about this project, I did a bit of testing and I thought, well, can't we use Azure's cognitive services? So if I search for these here, you probably have heard about them. Cognitive services, they have got a lot of different functionality available right out of the box. So here's, for instance, vision-based services. And we find computer vision here, and we find custom vision down here, which is what I ended up using. And I thought, well, what about computer vision? Wouldn't that maybe do exactly what I need? And I had a look at this. So you see what computer vision can do for you is you give it an image, whether that's available as at a URI or you upload it, and it's going to tell you, are there persons in there? What are we looking at here? Is this the scene out in the nature? Is it inside? What is this? And you've got a couple of images that you can test here. And then there's other pre-built cognitive services like this one here, which looked very promising. Read text in images. So here we've got an image and you submit that and we can see that it's going to find the words that are in there. Sorry, have a nice day, see you soon, bye. So really good detection, and I tried using that. The problem is that these services that are used here, they only work really well if there's a context. And by context, I mean there has to be more than just one single character. If I try to upload the word puzzle that I have here, it's not going to be successful. Actually, we could try that just for the fun of it. So let me see. Where's that? We could totally come on, failed to double click here. We could use this here, open containing folder. I don't know where there is located. There it is. testpuzzle.jpg. So let me copy this. I want to give this a try. There it is. Browse. We're looking for this test puzzle here. So it's apparently doing something. There we have it. So this is the this is the result. So it found looking good. It found a whole lot of individual characters, and oh, to big surprise, it really improved. Look at this. So this definitely changed. Oh, now the question is, what did it find? Right, it found those words here. You see, it found those words from the list of words. I thought for a second it would find the words directly in here, but I'm actually sure it didn't. Otherwise we would see them twice here. So let's just look at this. There's comb, there's razor. Yeah, it found all of these. And it has literally no idea about these individual characters over here. You see, it doesn't even return all of them. So it's only looking for words, and it needs the context of, hey, there are words in this, and it cannot deal with individual characters. So even if just uploading one single character image it would not always be successful. So I thought, well, that's not it. And instead I went with custom vision. I was also kind of happy because I think that's a bit more interesting than just using what is there out of the box. So long story short, while I was talking, maybe you have registered for Custom Vision AI, and you would start by creating a new project there. Now you see there's all kinds of information here. Every project has got a name. It is a description that you can use to, well, easily remember what you're looking at here. Then if you're signed in with your Azure account, you can pick one of the resource groups that you have or the subscriptions. I'm using my Visual Studio Enterprise subscription here. And then you have to decide, what is this project about? Is it that you want to detect something, or is it that you want to classify images? Now, as I said, we want classification. We're going to upload a set of predefined images. We know that these will be the ones that we're going to detect. And we don't want to look for anything specific within an image. Now, depending on what you select here, it's going to use different models. Then it wants you to know, well, what is the classification type here? Can there be multiple things that are available per image? Like you're looking for colored animals. So is this a red dog or is it a blue cat? I don't know. That would be 2 tags, color and breed or type or whatever. What we need is a sorry, my voice. I don't know what's going on, losing my voice here. What we want is multi-class. We want a single tag per image. If we upload something, we know that is A, B, C, D, E, and so on. And then there's predefined domains here. And it seems like there are optimizations depending on certain use cases. So I looked through them, and well, what we want to do was not about food, it was not about retail. There's a general compact, and there are, what it says here, if you look at the help, there are lightweight versions that you can also export to other platforms. Like for example, iOS has also got some AI features built in that you can use, some machine learning features. So you can export the model and then maybe run it locally, which would also be something that we could try as a follow-up to this stream, make all of this run without the cloud, but getting ahead of myself. We are creating a general thing here. So we would enter this here. I'm gonna call this my test project. So I'm gonna delete it afterwards. Let's create that. And you end up with this UI, and there's not a lot to do here. Actually, you would upload an image, and then tell the system, what are we looking at here? So if I add images here, I would look at my, let me see if I can find an image. Gotta search for one. I would look for custom vision test. So I upload an A here, and then I have to provide a tag. And now the tag is what I get back. If I call the service later and let it detect something, it will tell me what the tags are. Now for me, it made sense to just map this to the character that we're using. So I would label this as an A, and I'm gonna upload that. Boom, done. So now it knows this is an A. And I'm gonna keep on uploading all the characters from A to Z. And when I'm done, I would train the model. It won't let me do this here because it says I need at least 2 tags and 5 images. So that won't work. So you need to upload a lot of data in order to train that model. Now, since it's probably not the most interesting thing here to watch me uploading gazillions of individual images, I'm gonna switch back to the project overview and use a project that I created before. It's the ABC Vision project. Here we have it. And you see I've uploaded a lot. Actually, you can see it here on the left-hand side. I uploaded 34 C's, 32 D's, 32 I's, KLM. So about 30 for every individual character. It's important, and it's going to warn you about that the number of images is about evenly distributed. So it's not okay if you upload, let's say, 2 images for A and then you would upload 10 images for B. It's going to complain. It says the result will not be optimal. So why do I have so many characters? Let's just look at this. I mean, there's 32 different X here. There's 2 reasons for that. The first one is, if I go back here to my image, do I still have that open? There it is. This is a pretty clean font here. However, there's no guarantee that every word puzzle is using that very same font. So I thought we should make the recognition as good as it can ever get. So I uploaded not only these characters here, but actually characters from different fonts. And I used different font sizes, because I thought maybe sometimes the letter is a bit blurry and other times it's a huge font, and I wanted to be sure that it detects everything. So that made me upload a lot, and I did all of this manually here in the portal, only to realize afterwards that there's an actual RESTful API that you can use to upload and train that model. So the next time I'm doing something like this, I'll definitely write some sort of helping application to achieve this. So this is reason number 1. I wanted to recognize a variety of fonts. The second thing is that whenever I tested this, and I tested it from within my client application, the results were not really good. And so sometimes it would recognize a character, but the next would fail. And so I kept on improving the model, and I show you how that works. So you can train your model here. You click on train, it's doing its magic. And as a result, you get a screen like this. It's gonna tell you how precise is this model. So give them any image and you get back a value. How likely is that value correct? And I ended up with approximately 94%, which is really good. And then it tells you what is the recall, what percentage did the model correctly find from those that should be predicted correctly. And again, I'm up to 94 there. And what is this here? I don't remember that. Performance, summarize, position. So this is kind of like the total of the precision and the recall, and I have a 98%. So that's really good. And you can test the model. You can test the model by uploading an image. So if I, where is that? Here's quick test. You can browse local files and I can give it any character like this here. You tell it which iteration to use. That's also important. Every time you upload something, you have to retrain the model and it's going to generate a new iteration. Now it can happen with machine learning that if you go from iteration 1 to iteration 2, that the results are getting worse. So you degraded the performance of the model. And in that case, you don't want to use this last iteration. You want to stick with the previous one until the next one is ready for deployment. And so you always want to have a look at these performance numbers. And in my case, the models got always better. So the latest iteration is what I'm using from my client. But anyway, you see here, it says with a probability of 98%, this one here is an L. So of course, then gonna pick this most probable one and not gonna claim that this is an F, which would be 1.1%. So coming back to, I said there were 2 reasons for me to upload that many letters. First one being that I wanted the model to be precise. The second one being that whenever I tested the model from my client, it would not return very good results. And after a while, and after creating more and more iterations, uploading more and more images, I figured, hey, hang on, there's something wrong here. So here's what I did for testing. I took, for example, this one here, the E. I uploaded the E here to the portal, and I let it detect what is that, and it returned me, hey, I'm 99% sure this is an E. And then I used my client app, and I uploaded the very same image to the very same model with the very same iteration. And it told me, yeah, I'm about 50% sure this is an E, and I'm about 40% sure that this is an F, but I'm actually certain that this is an X. I'm like, what is going on here? And this happened kind of randomly. And it turned out that the reason was that the client library that I was using had a bug apparently. So when I started streaming about this, I realized, hey, there's an update. They updated from version 0.12 beta or alpha to 1.0 stable, and suddenly it would all work and I would get exactly the same results like I did in the portal. So what I learned now is you probably don't have to upload that many images. That's a bit of an overkill, but it doesn't hurt either. So, by the way, looking at the chat, thanks for following. New follower, always appreciated. Right, so this is the custom vision portal. Now, what are we going to do with this? Well, if we go to the settings, I'm not going to do this here because I'm not going to reveal any secrets here. If you go to the settings, you'll find that every project that you create has got a unique endpoint. It has got a unique API key. And using these credentials, you can talk to this custom vision AI using RESTful services or using a client library. And we will have to include these endpoints, this information, these secrets somehow into our application. And hopefully I'll be able to hide them here. Well, even if you see them, it's not going to be a big problem. I can just change them. I can rotate the keys. But of course, if you've got a lot of image recognition going on, this would reduce my credits that I have available. And eventually I would have to pay for others using my services. So going back here, let's start by going into the .NET Standard library. That is part of the project. And this contains one static class called image processing. This is where we put the method to split our image into sub-images into individual streams. And right there, I'm going to add another method, and that method is what we will call, in order to pass an image wrapped in a stream to the custom vision AI and get back the information, what are we looking at here? Because eventually, when we have all of the result values, we want to pass this to the algorithm that then starts searching the words inside of this grid. So let's start by adding a method, and everything in here is going to be simply static methods. So this is going to be a public, let's start with a void, and I'm going to call this predict character. And as always, when you work with the APIs that you have available for Azure, it's very likely that this is going to contain some asynchronous code. And I like to stick to the conventions, and so I'm going to call this predict character async. And the moment you have something async, this should no longer return void. So this is going to be a task of something that I have here. And I also know that, well, if it's async, I'm probably going to use a wait here. So let's fix this and add the async modifier here. Okay. So with that, we are ready to begin the implementation. But what do we actually have to do here? Well, let me go back here to the browser. To the browser, I said, there it is. And I want to show you the documentation here. The request is enough for Azure SDK. You have been routed to newest product version. What? The request is not available for Azure SDK for .NET. What am I looking at then? I don't know. It seems exactly like the page I am looking for. So anyway, so this is the documentation that we have here for, well, working with what is called the custom vision prediction client. And so there are two ways of, there are two ways of using this custom vision AI. Either you directly talk to it via RESTful services using JSON, serialize this, serialize that, or if you're in a .NET project, you very likely will want to use the client that is available, and that's what we have here. I'm going to drop this here on the chat window too. Predict image async. This allows us to predict an image. And when I started this project, like I said, when they went from version 0.12 or whatever to version 1.0 stable, the APIs changed. And I think now I understand why it says the page is no longer available. Let me double check. Now that I say it, it said the page is not available, right? That's because, yeah, that's because this is still this no longer exists. There's predict image async. Yeah, right, so there it is. That's what we want. So they changed the methods. I think they split it up. Now there's classify image and there's predict image. So if you remember, when we set up the custom vision AI, I had two choices: either detect what is in an image, detect content, or classify. So what we want to look at is classify image async. Again, I don't know what this is about. So this is what we actually want here: classify an image. And you see, it needs all kinds of input data, like a unique ID, the name of the model that we want to use, because you can have multiple projects, and so on. But I think let's just use it, then it becomes clearer. So first thing we need is that client, and that means we have to add the client library here. Manage the NuGet packages here. I can see if I can just find it, custom vision. But there's probably going to be, I just thought there would be a lot, but there aren't. So you see here it is, Microsoft.Azure Cognitive Services Vision Custom Vision.Prediction. I wonder what the length limit is for NuGet package names, but that's the one. And here's the other one that I only discovered later. So there's the custom vision.training. This is what you could use to upload the images and tag them without having to go through the portal. So we're going to add this one here. What is this one here? Universal Microsoft Cognitive Services. Oh, that's not by Microsoft, that's something else. So this is then probably based on top of the RESTful APIs, just different implementation. There's also one for, what is this? SAM plugins. That seems to be one for a plugin. Oh, this sounds promising. Oh, maybe get back to this later in one of the next streams. Make it easy to use these models offline. Right. So remember, when we looked at the portal, you were able to create these compact models. So maybe that would be an option. Anyway, this is what we want now. Let's install that. There we go. So maybe one more word about training and uploading these images. You can imagine that what I did here, that was quite some work. And maybe the question is, how did I get all the individual characters? So if you look at this here, we've got how many? We've got about 30 characters each. How did I get them? Well, initially I really used copy and paste. So I opened up, like here, I opened up Paint and I just highlighted this and oops, of course not like that. I selected this and I saved it as an individual image. But after like 3 characters, I was like, man, this is gonna take ages. So here's what I did. I created a little utility that allows me to extract characters from TrueType fonts. And you can find that over in the project here. You see here's a utils TTF converter. Quickly going to open this. So there's a subfolder fonts in here and another subfolder called export, and export contains individual characters for each and every TrueType font that is in the other folder. And this is just a simple shell script here. So I don't know, why can't you zoom with Control+ in Chrome? It's the only browser where this does not work. Go back here. Zoom, there we are. And I'm running this on Windows in a Git shell. You see what it's doing? It's just it's iterating over all the font names, and then for each of the TrueType fonts, it's calling convert. And this is using, oh man, what's the utility called? See, I forgot the name. Convert is, yeah, right, that's Image Magic. So if you haven't heard about that, Image Magic with CK, there it is, imagemagic.org. I'm going to put this in the chat window too. Amazing utility. And this is available as a, well, as a command line tool. It works across all platforms. However, I was not able to execute this on macOS. So my main machine is a Mac, but it didn't work there. I switched over to Windows. It was fine there. You can do pretty much anything with images. So it's a bit like the 6-labels image sharp library, where we can manipulate images using C# code. This is command line based. You can add text, you can crop them, you can, I don't know, whatever you want to do. It's like an image editor in the command line. And I use that to generate the individual characters. I would just have to upload them and tag them. And this, of course, saved a lot of time. Now, coming back here to Visual Studio, meanwhile, it has downloaded and added our NuGet package. And that means we are ready to create our client here. So let's do just that. Why not call it client if it is a client? And that's going to be a new custom vision. What is it called? Maybe we should just add the appropriate using up there. Then it would be easier to figure that out. So that was Microsoft, Azure, Cognitive Services, Vision, Custom Vision, Prediction. There it is. And now it should be able to predict what we want here. Custom Vision Prediction Client. Sounds good. And this client now needs some input in order to work. So one of the things it wants is an API key. So we gotta get this from somewhere, right? And I want to make this a parameter here to this method. So we don't hard code that in here, but whoever is using that should be able to provide their own key. So we're going to have a prediction key in there. And the other thing we need is an endpoint. An endpoint is also just a string. And this is something that you can find on the Custom Vision AI portal. And like I said, I want to keep this a secret. So I'm trying my best to really make it a secret. And that means we're going to, well, add that here to string endpoint. Now the client is there, and using that client, we can now go ahead and, well, classify an image. That's going to return some result. Let's see what that is. And there's the method. There's classify image. There's also an async version, which is what I prefer. We can use it to classify an image at a given URL. So you don't even have to have these images downloaded. You can just point it to something on the internet and use that. However, classify image async. And now it needs a project ID. So everything that you predict is associated with a project. That means we need a UI ID here. We're going to generate one. And we're going to again pass this into our predict character async. So whoever is calling that can define that project ID. So we need another parameter here. String project ID. That's the first one that it wants here. Then next it is looking for a published name. Now published name, this parameter here, this is something where I had to try a bit in order to figure out what it is. And I ended up looking at the JSON payload when using the RESTful APIs to understand what this is. This is really the name of the iteration that you wanted to use. So remember, in the portal, if I go back there, we can have different iterations. So if I go to performance, I've got 3 of them currently in here. We can tell it which one to use. So that's what I'm doing here. Mine is called iteration 12. And then finally, it wants a stream representing the image data. So we're going to add yet another parameter here. And I'm going to make this a stream image data. So this is what this looks like, and of course we want to await that. And now I want to use configure await. Notice how it proposes here to use continue with. I just installed IntelliCode the other day. So this is Visual Studio 2019. I switched to this, and IntelliCode is an improvement of IntelliSense. If you haven't tried it out, give it a try. It's really cool. You can find that here if you go to extensions, manage extensions, and you search for IntelliCode. And it is also, it's an AI, it's a machine learning thing that's going on here. It tries to predict what you're most likely going to type next, and here it predicts that I'm very likely going to type continue with, but that's not the case. I want to use configure await false. So why is it predicting that? Because it was trained using various GitHub or Git repositories. I don't know if it's GitHub really. So they made it look at a lot of code and analyze that and figure out what are C# coders very likely doing next. And so it figured that it would be continue with. And I also started training it on my own code, so it would really help me best. But apparently that wasn't quite as successful as I expected it to be. Anyway, we now got a result, and that result is now not an exact prediction, it's a list of predictions. If you think back to the portal, when I upload an image and let it predict that, it tells me I'm 90% sure this is an F, and I'm 15% sure this is, I don't know, something else. Now, we can get back all this data, and of course, we're gonna take the best match from that. So our prediction that we have here is something that we find in here. Our result, yep, now I got it right, contains predictions, and that is a list of all the predictions that we have. And here I'm going to use the first or default. I gotta add link here. So this is a list of predictions, and the first one, this is the best match. That's what I want. So we check. If the prediction is null, well, that's too bad. It didn't find anything. Then we have to return something, which brings us back to the return value. When we predict a character asynchronously, what is it that we want to know? Well, of course, the character. That would be one thing. The other thing that is maybe interesting to somebody who's using that is, well, how sure are you that this is really the character that you claim it is? So we maybe also want to return the probability. I don't know if we're going to use it, but maybe something that we return back when we process the results. So I could now add a separate class or a structure that contains that, but I mean, as of C# 7, I don't actually remember, I think it was 7, we can use tuples here. So let's just say we're going to return a tuple, and this is probability that we return here, and I'm going to give it names and a character. So this is what I want to return here. So that means if the prediction is null, we're going to return a probability of, I don't know, -1, and the character is an underscore. That should not be a string, but a character. Now, it wouldn't hurt to document that, by the way. If you look at code that I'm writing, you typically find a lot of comments. I'm omitting the comments here while I'm doing this live here on the stream, just to save some time. But this is definitely something that I would document. I would say, if it doesn't recognize it, the return value will be -1 for the probability, and it will be an underscore. I should probably learn how to spell probability, right? Probability, there it is. Thank you. And if we have got something, well, then let's return a probability of prediction dot probability, and a character of prediction dot tag name. That's it. And what is it complaining about? Tag name. Oh, tag name is a string, right? So what in the portal, we can assign these tags, and they are of course strings. It's just that I assigned single character strings. So my tags are A, B, C, D, E. So I know that there is only ever one. That means I'm just going to take the first one, which is a character, and that will work just fine. So that's our method here. What is it complaining about? Cannot declare instance member. Yeah, you're right. Public. Why is the compiler always right in the end? There we have it. Predict character async. So with that, let's start and try this out. And as always, I'm going to create a little test application to do that. So that means, well, let's first maybe see if it builds. All right, that's always the first thing here. Let's build that. And it succeeded. Great. So where's our test projects? Test apps. There's image splitter test. That's the puzzle solver. Now we're going to add a new one here. That's a, well, yeah, console app. Ah, you're smart, Visual Studio 2019. And that's going to be custom vision test. Let's create that. Custom vision test. And custom vision test, well, nothing too special in here. We probably need some test data, so let's add that first. And use AI in telecode. Yeah, I mean, try it now. I have already enabled that. Thank you. You see, this is what you get with IntelliCode. I don't know why this pops up now. I already had that before, and you can train it on your own code. So it's going to include that. Anyway, back to this here. We need some test data. So let's add this. I already had that open somewhere. There was this one here. Or is it not? No, that's the wrong one. This one. This one? There we have them. AELSTN. Just some test images that I'm going to add in here. And as always, or as with the other projects, I'm going to make these. I'm going to open them all apparently because I clicked the wrong key. Now I'm going to make these embedded resources. I'm going to the properties here. Build action for these will be embedded resource. All right, that's fine. Has it updated all of them? It has. Well, let's close them again. There we have it. So now, of course, we can go ahead and load these and pass them on to our method. And well, yeah. So let's do the. I think I have this already somewhere. I don't need to retype that. There's the image splitter test. So there's this one here. We're getting to the current assembly. I need to resolve that. We need to get manifest resource names. However, this time we not only want this one that ends with test puzzle, but we want everything that ends with, what are they, PNGs? All the PNGs, and not single, but actually we just need where. And I'm missing system link, that's why. And that's not a string then, but that's resource names. Is it happy now? All the resource names that start, that end with PNG. Good. And then we can get the, yeah, right. So that means we need to iterate over all of that. Let's add a for each here. For each var resource name in resource names. we can get an image stream, and of course, having the image stream, we can get back our probability. And the character, we can get back the information character. Let's create that tuple here, and that's image processing, which we also have to reference. Add reference to puzzle solver lib. Yep. Predict character async. And now here's the input that we have here. So the first one is the image stream. Then we need the prediction key, which is still a secret. We need the endpoint, and we will need, well, some sort of project ID. And all of these have to be configured. So problem, this is async. I could now worry about making my main method async and whatnot, but here in this case, I really don't care. I'm just gonna call result here. I don't care if this is blocking. In that specific case, it's just a test application. When we move this then into the function, into the Azure function, there we will properly await that here. So with that available, we can use a console write line here and output what we found. And say prediction for our resource name. We can output the probability here. Maybe format that as a percentage. Sure, this is a, and output the character. Full stop. And then let the user know that this is done. It has really done something, and we may want to add a console read key here. Okay, so that should be it. Now we need these three here. Okay, so we need a string prediction key. We need a string endpoint, and we need a string project ID. And like I said, you would find all of these inside the portal. If you go to the Custom Vision AI portal, you can find them in the settings there. I want to do the following. I want to keep them a secret. I want to have them as part of my solution as long as I'm running this here locally. I also want the values to be available and retrievable using the same technique when I later deploy this to the cloud. Now, there's different ways of achieving that. If you have worked with ASP.NET MVC or ASP.NET Core, you know, there's the, what is it called? Local settings.json or local.settings.json. And you can, or you have that file, it's part of the solution being generated, and whatever you put in there will simply not be checked into source code, which is kind of convenient. And do we have that already in here? There it is, local settings JSON. You see, I have it here too. This is where you can put those secrets that are specific to your client installation. And if you submit that, well, it's not going to be deployed. And by excluding this from the commit, it will not end up somewhere on GitHub. That's of course a big advantage. You could also use the secret manager. We could use the key vault, but I'm going to go with this approach of having this JSON file in there. So that means we're going to add something in here that allows me to read configurations. I'm going to add, and this is a bit of a test now because I haven't thought about this really, but it's going to work. It will be fine. What we need, is a library and something that is always there when you're using ASP.NET. We are looking for the Microsoft. No, we're not looking for Microsoft. We're looking for Configuration Manager. So this is what you can also use in a console app, but you have to add it manually. So there it is, System Configuration Manager. 4.6 preview. Is there a stable version? I prefer a stable version. Where is it? System configure, there it is. So it says here, provides types that support using configuration files. Awesome. So that's just, I think, what we want here. Hope that's the right one. Yep. And now there should be one that allows us to load JSON. Can I search for that? No packages found. So I know that for the other one, the one for ASP.NET, you can get this. You can get this one that supports JSON. Now, a pop-up is just appearing here on my other screen. No, please don't update anything now. Thank you. I just wanted to update my streaming software while I'm using that. It's probably not a good idea. Microsoft Azure Configuration Manager. So let's see what we have here. Maybe I'm mistaken. Well, let's just go ahead and give that a try. So using that configuration manager, using system.configuration, app settings, connection strings, So let's try this. Let's add this file first. So what is that called? Called local settings.json. I'm gonna add this in here. Add new item. Local.settings.json, just like we would in a web project. And I gotta put some value in there. No, quickly, let me look that up. Yeah, maybe we start with just the test. I mean, it doesn't have to be the secret. So this is some key, and some key is some value. And I want to be able to read this. So that would be the ultimate goal in here. Now, how would I build this configuration manager? I gotta look it up. I don't remember. Configuration manager, read JSON. Yeah, app settings JSON. How to read in ASP.NET Core. Looks promising. This had a few twists and turns. Aha. New configuration builder, set base path, add JSON file. Coding with Stack Overflow. There we go. New configuration builder, and apparently not. ASP.NET. That is ASP.NET. I don't want ASP.NET. Configuration manager .NET Core console app. That's what we want. Configure in console applications. So why do I have to look this up? Just quick info. When I originally thought about that, I used an XML file, and I later read about this, and I thought, well, I don't want to read XML here in different file formats. let's just use what is there. So we've got a console app. Yeah, great. It's all good. Oh my God, you're starting. Configuration API. Okay, what are they using? Microsoft extensions.configuration. So I did add the wrong one. Let's fix that. Custom vision test, manage your packages, installed. So we want this one here. What is this one about then? Let's use that one. There it is. That's the one I was looking for. Microsoft Extend Configuration JSON, because that one has a dependency on configuration. So that should add all the right ones now. Wow. It's going to add all the packages there are. So configuration file extensions JSON. Now we added a file, that's good. Edit and add the following lines to the file. And she will be copied over to the output directory. What? Working directory, just refer to it by name. Good. Is it done? It's done. So what is installed now? Okay, so we've got this one here. Now let's go back to this. Let's do that. Now it can resolve it. New configuration builder, JSON file, app settings. So I did call that local.settings.json.build, and now I should be able to access that, right? Hello, config name. Well, sounds promising. Console.writeline config, and I called that some key. Let's try this. I don't believe it until I see it. Custom vision test. There we go. Aha. Well, that didn't go too well. Value, config some key. So do I have to copy this over? Do not copy. Copy always. Build action, and that is probably content. Let's give it another try. There it is. Value, some value. Yay! So we've got our config there. Great. Now using this, I can enter my secrets into this test application, which I am about to do. So I gotta switch on here my secret screen for a second while I'm copying this over, and then we will be right back. So let's see if this works. Secrets. Yep. So sound should still work. Right. I'm gonna paste this in here and add my values. We need a prediction API key. Even if I told you the value, I mean, wow, this is long. So the prediction key, this is just a long numeric value that you have here. Then we have got the API endpoint. That's a string. And that's a string in the format of, well, some region, like in my case, westeurope.api.cognitive.microsoft.com. This is also that you can read from the portal. That's not really a secret, by the way, but it's something that can be configured. And then we have got the project ID, and the project ID, once more, this is something that we can read from the portal. This looks like a GUID that we have here. I think it actually is one. So I've got these three in there. Save this here and make sure that this is not checked into GitHub. If I can open GitHub. Who would have thought that the trickiest thing to do is launching GitHub? Where is it? GitHub desktop. That's interesting. Start menu. I could probably do this afterwards. Maybe I will. So I don't want to leave you here on this secret screen for too long. Here I am. Hey, welcome back. Okay, back to our app here. So I can load my values now. They have been added to this local setting file. I did delete something, didn't I? There we go. So the prediction key, that is now config, and the value is custom AI prediction key. Then we have got these two here, and that's the custom vision. I'm gonna look up the values here, and point. And the third one, that's the custom vision AI project ID. Prediction? No, prediction. There you go. How hard can it be? Prediction key. There it is. So I'd say we give this a try here. Let's just run this, see what happens. Argument null exception. Parameter input. What's the deal? What is not working? What is null? So you see, I'm a bit in trouble now hovering the variables here because one of them contains the secrets. That's of course a bit hard here. So let me check. Let me go over there. We need this, we need, come on. We need this here. So I could probably look at the endpoint if that contains a value. So that works. So it seems to read these things correctly. So that's not the thing here. Let me quickly check the others. Just a second. Yep, I found it. I gotta fix this. So I forgot to add a value, or I added it incorrectly. There you go. So this is not custom AI project ID, but custom vision AI project ID. So this one here was wrong. Let's try this again. My co-host fell off. Sits. Look at this. Prediction for A, 100% sure this is an A. How can you change that here? Properties. Increase the font size here. Maybe make that 20. There we go. You see, it says AELNST. This is what we looked for. It's actually super sure what they are. It says these are the characters. So it's not only very sure that it found something, it's also very sure that it found the right thing, which is even more important. You can see the prediction key. That would not be good. Where's the prediction key being shown? I mean, it's not the worst thing to happen because I can't change that. And even if you end up using that, that would oh, in the breakpoint, yeah, right. So thanks. I thought so. It would show up somewhere. It was probably in the local values. Yeah. So this is always the thing when doing these live streams. It's super easy to accidentally stream out some secrets, but really you could now go back in the stream. You could look at the recording and use this key, and you could set up your own project. Well, what would you get? You would have a custom vision AI to predict characters. Now I'm going to change this key afterwards, so even if somebody now starts firing at this custom vision AI, they would maybe, I'm not even sure. You have so many of these free calls to this API, but eventually it would eat up my credits and then I would run out of credits. Well, so what? It doesn't really cost me anything now, but of course I want to avoid that. But thanks for pointing this out, and I want to have a even better look at the debugger. Anyway, so this seems to work. But thanks for bringing this to my attention. I really appreciate that. Very valuable feedback. So this is what we have now. We've got this working locally, and as always, when it's working locally, when it's been tested, we can move it over into our Azure function. So now I'm looking at the clock, and I think this will be the last thing that we do today. Again, as always, spending more time on this as expected. So when I started streaming, had a bit of a chat with experienced streamers, and they always said, well, you're only ever going to manage to do half of the work that you planned to do. I guess it's right. So here's our puzzle processor. This is where we ended up. We ended up splitting our input image into sub images, and now in here we can now call the very same method, right? Yeah, let's just do that. Let's just say image processing dot predict character async. Now we can really do this. We gotta configure wait false here, and we can then optimize that a bit. I gotta see what are the input values that we need here. Well, first of all, we will need some, the first one is the stream here. We will need some image stream. And our image stream, that will be whatever we get back from these sub images. So we're gonna have image stream, that sub images 0. There we have it. Oh, I already have that. So I'm gonna call this, I could just redefine it, but I don't want to do that. So let's just say this is sub image stream then, like that. So we'll have to iterate over all the sub images here. Actually, why not do this right now? So here's how we handle that. We could do a for each, or we could just say we want to predict them row by row. Let's just say we have an integer here that says for row equaling 0, row lower than, we've got the number of rows here somewhere, row plus plus, and then in there we're going to go over the columns in there. So that would also be 0, column lower than number of columns, column plus plus, and for each of these we're gonna grab the sub image in there. Right, so that's one thing we need. It's gonna process the, of course not sub image 0, but that would now be, what is that now? Row times number of columns plus column. Does that sound right? I think so. Sub image stream, then yeah, once again it wants the prediction key and all that stuff, so let's grab that from over here. It needs these thingies here. So again, we got to find a way to get them from somewhere. I just be able to copy this here. And we are, again, of course, getting back the very same result value. Oh, that's this one. And once we have that, well, once we have it, we can output this, I reckon. And I guess that's as far as we gonna go here today, and that then leaves exactly the right amount of work for the last part of this stream, I think. So that works out quite well. So what are we gonna do with this? Let's do a debug. No, let's do a, there's a logger somewhere, right? Where is it? Log information. Well, what can we log here? We can log predicted, and then let's just say whatever it found in there. Predicted character with a probability of that will be percentage again, and that would be probability of probability percent. So that should give us 196 of these information logs in there. So what about these puppies here? Well, just like before, we need to get them from somewhere. And now I also have a local settings.json in here. And I quickly got to check that, see what's in there, because I don't remember. Yep, so this is already, no, that's the wrong one I'm looking at. I should look at the right one. So let's make this here the startup project. And is it already in there? No, it's not. So I'm going to copy these values over, the big secrets that you already saw. Just don't want to make it more obvious than it has to be. There they are. Go back there, close this, close that, and back again. The monkey keeps on falling off the throne. I need to build him something. So we have got a configuration in there, right? Where is that? Don't we have a configuration yet? Why don't we have a configuration? There should be a config inject. Why is there no config inject? Who forgot to add the configuration in there? Oh, nobody. Because, yay, right. So because we're not using the config, we're just using the environment. That would work just as well. So here's the thing. We can use this here. We can use environment. Get environment variable, and that will pick up the value from wherever it is stored, which is really convenient. So I could in theory define those as environment variables here, but that will pick it up from the config file, and it will also pick it up from the Azure's app settings if we deploy it to the cloud. So that's of course a nice thing to have. I'm just gonna change these here. Right. So that should do the trick. Let me double check something here. No, that's good. Right, so what are we doing now here? We're iterating over all the images that have been returned, and we are predicting them one by one. And we're doing this whenever the blob has changed. Why not try it? I mean, what can possibly go wrong? It's good to go. This is running. Oh, it's still working. So now it needs some input, which we'll find, or which will trigger by going to, where is it? Not here, not there. There's the Storage Explorer. So here I've got the Storage Explorer with one of these puzzles in them. I'm just going to change something in here. I'm just going to change one of the words. Almost done. Let's just save this. This should trigger the function. There it is. Blob change detected. It splits the images. Oh, there we go. I see it starts predicting. So the function is now processing this. Why is it only finding L's and C's? That's a bit strange. Why are there so many L's? Let's look at the image. Where is it? That doesn't look right. You see, predicted I. Huh? What's going on here? I don't know what that is now. That looks strange. Okay, let's stop that here. So what am I doing there? Row times number of columns plus col. That looks right, is it? I'm going to predict that. Let's tackle this differently. So first of all, predicted character at row. I want to output this here. I'm going to put the row in there. Actually, I want to do it this way around. So it should be column row. Column row with a probability of this. So that's one thing that I want to change here. And yeah, let's just try this again. So this looks weird. So question here on the chat, what is my son's homework? I mentioned this in the beginning. So the homework assignment was to find words in a word puzzle as we see it here. Not using the computer, but it was just part of, I don't know exactly why he had to do this, but part of his homework was this puzzle. Not exactly that one, a different one. And well, he just struggled finding the last or the last two words, and my wife looked at it and she didn't find it either, and I looked at it and I didn't even bother finding the words manually. I just thought, let's use some artificial intelligence to solve this problem. And so the homework assignment was about 6 weeks ago. Of course, he's long done. He found all the words eventually, but I'm not done fixing this. That's why I'm still working on this. It's a fun side project showing what you can do with AI, with custom vision, and with Azure services. And that's why I'm doing this here. Let's try this again. Where's the Explorer? We're gonna trigger that here once more. And again, I'm just gonna change that. Let's see what this is doing here. So it's LCGCCC. That's completely wrong. Is it? I mean, that's completely off. So what's happening here is that it either the prediction is completely off, that would be one thing, or the images that we are splitting are not the right ones. What is this? Let's just wait for it to be done. So 9. It's funny, it's only detecting I's and L's. let's stop it. So let's double check if our image splitting works. Luckily, we've got the image splitter test here. There it is. And it's using the very same test puzzle, and it's writing the images into our output folder. So we should be able to find, let me just run this. Set this as a startup project, and let's clean that and run it and see what happens. That's interesting. Oh, there we go. Bin debug. And that's definitely not just I's and L's and T's, right? So these are actual characters. So the question is this again some sort of bug in the client? Did I use a different version? Who knows? Let's figure out what is going on here. So this is done. It's generating the right images. We can be sure about that. Or can we? Yeah, I think we can. Let's look at the puzzle processor here. What is this puppy doing here? It's going to split the image using the incoming stream. Now, of course, the question is it using the right parameters? But why would that just be L's and I's? This doesn't make any sense. It really doesn't make any sense. So maybe, here's what I want to do. I want to just verify if this works in the Azure Function 2, if it's really creating the right sub-images. So let's just save them somewhere. Let's go ahead and add some code here to the image processing, just for the sake of debugging that. So these are already PNGs in there. Okay, so let's go back there to the image splitter test. And here I'm going to create a file and save that directly inside the function and see if we're getting the same result images. I need to copy this here. For each in sub images, let's open a file stream and save that. File stream, file open. Okay. So let's see if this is helping us figuring out what is going on here, because that's a bit surprising. And it's different from what I had initially when I had this malfunctioning client that would return incorrect values, because there it used at least different characters. It wasn't always the same set of characters, but this is a bit weird that it's just I's and L's. Let's go back here. Always having trouble finding the Explorer. There it is. Exception while executing function. Bad request. Custom vision prediction. Yeah, okay, so this is expected now because now the streams are no longer at position 0. So if I save them, the stream has moved to the end so it can predict them. But now I should be able to see this somewhere. Open containing folder. Let's just see, where did it drop that? Ah, there you have it. So that's why. See, this explains it. Something is wrong with the values. Apparently I'm using different values here. And I guess that because of the because of the separated vertical one, it detects them either as I's or L's, because that's the closest thing that you see there. Okay, that's good, because this is something that can be fixed. So what is going on here? Split image, that takes the stream, the columns, the rows, offset left, offset top, horizontal spacing, vertical spacing, width and height. So the order of parameters is right here. Then I can get, well, let's not got rid of it. Let's comment it out. So the order is correct. The question is, what are the values? So num rows, columns, columns, offset left, left. That's good. Top, top, cell spacing horizontal, cell spacing vertical, cell width, cell height. That's also good. So that means there must be something wrong in the blob. Let's go there. Let's check this. Properties. And see. I can't resize that window, can I? But only at the top. We have it. So let's check what is in there. And I want to compare this to the values that I have in my test application, because there it's obviously right. So program.cs. We need this here. Oh, come on. I just move this here so we can see this. Maybe like that. Properties. So what do we have? Cell height is set to 40. That looks good. Then we have cell spacing horizontal spacing 11. Then we have got, so cell spacing horizontal is 11. Then, hello, Genzo 0. 12, then we have vertical spacing 12. We have a cell width of, that's 41. Could that be it already? Then we have got a number of columns, 14, number of rows, 40. There, offset left is completely wrong. So offset left is 40. That's the correct value for this image. And offset top, where is it? 115. So that of course explains it. And now let's save that. Let's give it another try. Let's run the Azure functions. No, I can really get rid of this now. I'm positive that this is working now. Let's remove this here. Let's run this. And what is interesting here, by the way, you see the function project was not running and I changed the blob while offline, and still when the function project fires up, it will detect that change. So there we go. Look at this. Now we've got the right characters here. And always in the 100% range. There's one thing here that we can improve. And I still want to do this today before ending this here. You see, this is taking really long. So predicting these characters is the longest running task in here. And we can do much better. So the prediction service can do parallel execution. And we are currently reducing parallel execution by explicitly awaiting each and every recognition here. So that's not necessary. Instead, what we want to do here is just create tasks here. So let's not await that here, but let's say what we get back here is a prediction task like this, and then we don't configure await false, we don't do anything here, and I gotta move this one out here. So in other words, I'm just setting everything up here. Just get rid of this here for a second. I'm setting everything up. I'm creating a lot of tasks, and then when we are when we've created all the tasks, let's just try and run as many of them in parallel as possible. And we're just going to wait for all of them to complete. This will be much faster. So we're going to use task.whenAll and all prediction tasks. We need that here. Configure, oh wait, false. So we need this here. That means we need a list of task, all prediction tasks. That's a list of tasks here. I'm going to add this in here. Prediction task dot add prediction task. So like that, we are waiting for all of them, and well, then we could just use the code that we have got in the solver to output the result, right? So if could you do that in a map rather than a loop? Comment on the chat here. What do you mean do that in a map? You mean do that in a map rather than a loop? Oh, you mean use link to map that over, to project that? Something like this? That may actually, we could do that. We could do that. So the intention was, yeah, you're right, we could do that. So let's do this. Let's go sub images, and for each of them, we're gonna select. So we're gonna select the stream here that's coming in. Let's call it stream. And that stream becomes this here. So I guess that's what is that what you're suggesting? So let's call this sub image stream. Now I resize the font here like that. And this here, and that would then be, yeah, either to list, or we don't even have to do that, right? So what are we getting here now? Oh, we could just do this here now. Sub images. The stream cut out. I didn't hear your whoa, my stream cut out. But yeah, that looks a bit neater. I meant for all prediction tasks. Bit like promise all of a map of promises in JavaScript. I'm not sure if I can follow, so let's see if we can get this right and then have a look at that. Okay, so that's the wrong type here. We need a task of something here, so that is probability, comma, character. And that needs to be double character. Well, not that, it's just double character. Now it's happy. So the intention of this here was, and that's maybe when you say the stream cut out, the intention of this here was to really do this line by line, or column by column, and then line by line, just to see that the character at position 0, 0 is really the one that we detected. Yeah, so the stream, just for information, the Twitch streams, they are at least 7 seconds behind. So for me, depending on the browser that I'm using, a Twitch stream is about 3 to 4 seconds behind if I'm using Chrome, because they've got an optimization in there. And for other browsers, it lags as much as, yeah, 15 seconds behind. So that's making the chat a bit out of sync here, unfortunately. So let's get rid of this here. I guess we don't even need this. So let's just simplify this further. Let's just make this enumerable here. I mean, why bother? Like that. So now let's go back to what I said before we optimized that. Let's go to the puzzle solver because that has got some output in there. Or should we do that? Well, you know what? Why not complete it today? It's just one more step here, really. Let's complete this project. I think it's going to take another 10 minutes or so. I think I want to finish this here. So here's what we do. Looking at that code here, this was from session number 1. It's Kim Philpott's Word Finder 2000. If you're not following Kim Philpotts here on Twitch, go ahead and do it now. Awesome streams. He's doing great content, and he wrote me the algorithm to find those words here while on a plane back home to Australia. So this word finder, I'm not going to spend too much time walking through this. The way it works is that it wants a grid of characters. So that's how it's working. So we're going to create that now. So that's going to be a new character grid here with number of rows, number of columns. So two-dimensional grid. That's what the algorithm that he wrote is based on. And now we can again, yeah, I'm kind of re-add the code that I just had there, but this time I think it's necessary. We can then have a look at it again. Row lower than number of rows, row plus plus. Like that. And then we've got column in here. Number of columns, column plus plus. Just format that for me, Visual Studio, thank you. So like that. We know that all of our tasks have finished by now. So that means we can go ahead and get the probability for each of them, probability and the character out of this. And that would be all prediction tasks. Looking at row times number of columns plus column. And since the task, we know that it finished, we can just get the result there. I think. Oh, that's an enumerable, so we need the two lists here. Let's just do that. Let's turn this into a list so I can index that. Otherwise, it would reevaluate that. There we go. So there we can have our result for that. And with this, I can fill this letter grid here. I can go and say here at, so he did it the other way around. So this would be now row and column. And that would be character. Like that. Now I'm thinking, can I project that like before? So I would create the letter grid, all prediction tasks. Yeah, we can do that too. Let's just do that. All prediction tasks, dot select. And the prediction tasks become let's just move this in there. Let's clean this up. Oh, bummer. You see, now I don't know the row and the column in there. So I would have to remember. Yeah, I don't think this is simplifying it. So now I would have to figure out what is the index of the task that I'm looking in within the list of all prediction tasks, and then divide that and do the modulus and figure out which row and column this maps to. Or I would have to change the letter grid to a one-dimensional thing. So I don't think this adds anything here. We're going to end up with approximately the same amount of code. So I don't want to change something to use linked just because I can, if it's making it more complicated. So I think this is just fine here. So we're going to fill this here, and then we can, well, we can actually process it, I think. So what we have here is our list of words. Are they there? So there's words. Words is what we read up there from our meta information. Where is it? There. So we're splitting the input. And let's just pass this to the processor. So we're gonna say search word, and I'm gonna create a helper method to do that, I guess. And we tell it that the word is hidden in the letter grid. That's what we have there. And well, the word that we're looking for is word. So that means we're just going to go over that for each word in in words. Let's search the word, and we get back some result here. And we're going to add that to a list of found words search results, something like this. That's going to be a new list of, well, of something. I got to look up what that was. Where's our solver? Where's the solver? There it is. Static class, letter at position, search result. There it is. So that's also already in the library. So we can use just that. Using solver.search result. That's what we need here. Right, so that means we need a helper method. And yes, you can of course add methods into a function. It's not that everything has to be inside this big run method. So that's going to be a solver.search result, search word. And as an input parameter, we have got this character grid here, a two-dimensional grid. That's the letter grid that we pass around here. We are looking for a specific word to search for. And with that, well, we can run that. So it's solver.search for word inside letter grid. And that word that we're looking for, this is giving us a result. And I can use this method then to maybe add additional logging or augment it with information. Otherwise, it doesn't really add any value here. But thinking ahead, what we could do, it's maybe a good idea to have this method in here. So for now, I'm just going to return this in here. Or we could say, no, let's just leave it like that. But it really doesn't add anything, does it? It doesn't add. It's wasted code. Let's get rid of it. Why add something if it's not needed? So let's just use this here. Let's directly call this in there. So here we have it. Well, then we can output that, I guess. Right, there's nothing else to do. Let's add this here to the search results. Let's add this result here. And what our method returns, what our function returns is, well, we're returning. Let it just return search results here. Or return okay, no. Does it return anything? I'm not even sure if it does. Now, oh, so right, so this doesn't return anything. I planned this out differently, yeah. So let's just output it. Let's output it, let's see what it found. The idea is that the execution of this happens asynchronously, so you can pick up the result later. So this one is not returning anything. We don't wait for this Azure function here to complete, but last part of the stream, we're gonna add another function to pick up the results. So let's just output this here. I would say found. I'm going to put this in there. And then use result in there. And I wonder if result has got some toString that we can use. Yep, it has. So this is going to give us some information. Cool. All right. So let's run it. And of course I have to again update in here and tell it what words to search for. So hello and world are not in there. What are words that we find in there? Where's the puzzle? Perfume, hairstyle, mustache, plop change detected. Oh, it's already working because apparently I made changes. Doesn't matter. Let's add that. So that's perfume, hairstyle, this beard in there, hair, style, beard. Anything else? Brush. Let's give it a try. Save. And plop change, splitting. Is it gonna work? What? Yes, it did it. Look at this. Found, search result, true, perfume, hairstyle, beard. And the search result structure, that also contains where in the grid it found that. So we could even hand that back to the caller and say, hey, look, we found that at 00 up to 50, and then you could highlight it in the result set. That's great. That's more than I wanted to achieve, but then again, I'm 20 minutes over the over my target time. But anyway, things that were added on top of what I planned. I added the configuration instead of using an XML file. I unfortunately revealed my secret key, also some achievement, and we were able to pass the result of the custom vision AI back to the solver. So we're, I'd say, 95% there, which for the next part of the stream means find a way to hand the results back to the client, which is what I have here. So the results provider will be another function that the client can just call and say, hey, are my results there? Are we ready? Because we want the puzzle processor to save the results back to the blob. That's where we want to store the results. And then, of course, the whole thing has to be deployed to Azure and work in there too. And then we're done. From there on, it's then all bonus, like add a client. That's it from me. Remember to follow if you haven't already. Thanks for those who have followed. And I wish all of you a great remaining day. And already now, an amazing weekend. I'll be on vacation for the next... Wow, for the next 2 weeks. That means the final episode of this is gonna be, 3 weeks from now. That's long, but hopefully I'll see you there. 3 weeks, Thursday, 9:30 a.m. Central European Time. We're gonna complete this project. And until then, have a great time. Thanks for watching. Goodbye.